So now we're going to take a look at and start out with integration. So the key thing about integration, and one of the core reasons we start with the integration, is the objective is to find the area under a curve. So in the first half of calculus, we really focus on finding the slope of a tangent line, and that's where we did the limit definition of the derivative and things like that. The motivation for integration, this part, is to say, like, I have an arbitrary curve, and I would like to find the area under a curve. Like, if I have, like, some kind of curve here, my goal is to say, like, well, how could I figure out, let's say it's a very simple equation. Let's say it's y equals x squared. Okay, so it looks like a parabola, y equals x squared. And I would like to know, for some reason, I would like to figure out what the area is under the curve, say between 0 and 1. I would like to know what the area of that region is. Okay, so this is not something, this is just sort of like, what are the practical reasons for this? Who knows at this point? At this point, the motivation is just to say, like, well, how could I find the area? Now, the first thing you might do, if I had to ask you this and you had no knowledge of calculus or anything like that, you might say, like, well, you could do something really simple, and you might try to break it up into different shapes and things like that, but you could just say, like, well, I'm going to draw a bunch of little rectangles here, and I'm going to use that to, say, estimate the area. Okay? So I would say, like, well, I can find the area of each of these rectangles. And I would say, like, well, it's not exactly the same as the area under the curve, but it's pretty close. Like, it's kind of somewhat related, or, you know, like, it's like a close approximation. And somehow I could, like, eyeball, and I tried to fit it, and I could get, like, a reasonably good approximation. So in the beginning, the first thing we're going to talk about is estimating the area under the curve. And then later on, we'll talk about how we get the exact area under the curve. So for now, we're going to be just talking about, like, roughly speaking, what is the area under this curve. Now, there are 4 kinds of sums, and they're always the same process. If we're trying to find the area under an interval, we're going to split it up into different regions, okay, by interval widths, and we're going to draw a shape. For the most part, it's either a rectangle or a trapezoid shape. Now, how do we decide where the rectangle is? Well, there's left-hand sums, where on an interval, the left point of the rectangle touches the curve. Okay, so that's a left-hand sum here, because in a particular rectangle region, we're saying the left point touches the curve. Whereas in a right-hand sum, we would say the right point of the rectangle touches the curve. So in other words, the height of the rectangle is dictated by the right end of that interval. Or as a midpoint sum, what you would say is, suppose I'm trying to create a rectangle in this interval. To estimate the area, I don't want to use the left, I don't want to use the right, I'm going to use the value in between. Okay, I'm going to use the height right there in between and make a rectangle like that. Or the last step is to do a trapezoid, is to not make rectangles at all, just to say, like, well, I'm going to make a shape where I connect the endpoints in an interval. Okay, and if by connecting those endpoints, I can then construct what the area of those trapezoid shapes. So this is the only one where we don't use rectangles. So again, these are all ways to estimate the area. Remember, in this picture, the exact area would be like this region under the curve exactly, right, that I'm shading here. But we're using these rectangles to estimate that area. It's an estimation of the area there, okay? So let's just give you let's draw a nice picture for some of these, so we can get a good idea of how to set up the rectangles for each of them. Okay, so I have some kind of parabola here. And it's going to go from -3 to +3. Okay? And I want the area under the curve. So first, let's do the left-hand sum. And that's where I split it into 6 rectangles. So first of all, my intervals, this whole interval is 6 wide. And so my intervals are really going to be at like -2, -1, 0, 1, 2, and 3. Okay, so my rectangles are all going to be this wide. The real question is how tall do I make the rectangles? Well, if I'm going to do the left point sum, which I'm doing in red, my rectangles are going to look like this. This rectangle is going to be this high. This rectangle is going to be this high. The key part is that the left part of the rectangle, over an interval of the rectangle, touches the curve. At 1, it's like this. 2, it's like that. And so these are the rectangles that I would sum up, right? So for the left-hand sum, I'm doing the sum of all of these rectangles. That means I'm doing the y value times the interval. So each one is 1 wide, so I'm going to do 1. And this rectangle has a height of 3 squared because the function is x squared, right? So it's negative 3 squared plus 1 times this height, which is negative 2 squared, plus 1 times this height, which is negative 1 squared. It's always the y value, and because y would equal x squared, right? Because this is the equation y equals x squared, plus 1 times 0 squared, plus 1 times 1 squared, plus 1 times 2 squared. Okay, so 1, 2, 3, 4, 5, 6 rectangles. And I would just simply compute that. So this is going to be 9 plus 4 plus 1 plus 1 plus 4. 2, 10, 19. Okay. Now let's say we're going to do the right-hand point. Well, it's very similar, but when I do the right-hand point, my rectangles are going to look like this because the right part of the rectangle is going to touch the curve. Sometimes a right-hand point is going to be a bigger rectangle. Sometimes it's going to be smaller rectangles. It kind of depends. See, some of the green rectangles are bigger than the red. Sometimes they're smaller than the red. And so in this case, what I think about is, again, the width is 1, but then I'm doing negative 2 squared plus negative 1 squared. I'm going to drop the 1. 0 squared plus 1 squared plus 2 squared plus 3 squared, because this is final one. So this is 1, 2, 3, 4, 5, 6 there. So that's 4 plus 1 plus 1 plus 4 plus 9, also equal to 19, just by coincidence, by symmetry a little bit here. Okay, let's do the next one in this light blue color. Hopefully you can see that okay. Maybe I'll do it in brown. This color here. So this brown color one was we're going to do the midpoint. And so rather than using the ends of them, I'm simply going to do this a value in between. So it's going to be 1 times negative 2.5 squared plus 1 times negative 1.5 squared plus 1 times negative 0.5 squared. Midpoint just means that my height is based off of the middle of the interval on the x value. So it would look like this rectangle, like this rectangle, this rectangle, this rectangle, like this little rectangle right here, and then one like right here, like that. Okay. Plus 1 times 0.5 squared plus 1 times 1.5 squared plus 1 times 2.5 squared. Again, 1, 2, 3, 4, 5, 6. I just confirmed that. And then here I would use a calculator to calculate these up. So 2.5 squared plus 1.5 squared plus 1 squared. 2. And I get 17.5. So you see, these are estimates, so they're not all going to give you the same answer, which is totally fine because these are purely estimations. Let's pick an orange color for the next one. So for the trapezoid rule, you use the left and the right one. And I'm going to kind of draw it out again because it might be easier to kind of see. But rather than simply use the left or the right ones, we're going to use, so, you know, here's my negative 3, 2, 1, 1, 2, 3, okay, like this. So rather than do that, I'm going to create these trapezoids here. And add up, so they're not rectangles anymore. I'm adding up the sum of these trapezoids, okay? So trapezoids are always half the, 1/2 the base times the height. So we're going to have 1/2 times 1, because like, yeah, the height of these trapezoids, these are trapezoids kind of on its sideways, right? Because a trapezoid has 2 parallel bases like this, right? So you're going to take this height. The height in this case is 1. Okay, and then you're just going to average the left and the right points. So we're going to do 1/2, 1, this base times the sum of the 2 heights. And so that would be 3 squared, or negative 3 squared plus negative 2 squared, which is fine. So 1/2 times 1 plus negative 2 squared plus negative 1 squared plus 1/2 times 1 of negative 1 squared plus 0 squared plus 1/2 times 1 of 3 squared plus 2 squared. Sorry, I'm just going in the wrong order. Let's see, I'm doing this one here and here. 0 squared plus 1 squared plus 1/2 times 1 times 1 squared plus 2 squared plus 1/2 times 1 of 2 squared plus 3 squared. Okay, so this is 1/2 times 9 plus 4 times 13. 4 plus 1 is 5, so that's 5 halves. That is just 1/2, 1/2, 5 halves, and 13 halves. So 13 plus 5, 18, 19. 19 times 2 divided by 2 is just 19, so this is going to be 19. So it turns out, because of the symmetry in this one, like it turns out like A, B, and D are the same, but that's not always the case. So that's what we're going to do for each of these problems, is just find the area using all four methods, and you do need to know all four methods for most calculus courses. Okay. So this is 5 minus x squared. We're going from 0 to 2. The first step is to figure out how wide each rectangle is. Well, again, I'll kind of do a sketch, but eventually you're going to want to, you'll be able to do this without sketches. It's going to look kind of like this. And I don't know, maybe it'll go negative at some point. It's really hard to say. Or I guess at root 5, which is, yeah, it would be like here. You would stop here or something like that, and we would find this area. Okay, and so the whole interval is 0 through 2, and if I split it into 4 equal pieces, these are all 0.5 wide. Okay, and so I'm going to use the leftmost point. I'm going to use 0, 0.5, 1, and 1.5 as the heights of my rectangles, right? What did I use for the left one? It's going to be like this, then this, then this, then this, or something like that, right? I use the leftmost points. So this is going to be the width, which is 0.5 times the height, which is plugging in 0, 5 minus 0 squared, plus 0.5. This point is 5 minus 0.5 squared. This is 0.5 times 5 minus 1 squared. And then 0.5 times 5 minus 1.5 squared. Note that I don't use 2 because the height of 2 would not be the left point of any of my 4 rectangles. Okay, so I'm going to get 5 times 4 minus 0.5 squared minus 1 minus 1.5 squared, and then times 0.5. I got, when I added this up, 48.25. Okay. So for the right point, I'm going to do the exact same thing, except I'm going to use 0.5, 1, 1.5, and 2. I'm not going to use this 0 point, because this 0 is not the right hand of any rectangle. I would use this point, this point, this point, and this point. Okay, so it's going to be 5 minus 0.5 squared plus 0.5 times 5 minus 1 squared plus 0.5 times 5 minus 1.5 squared. Hopefully it makes sense. This 5 minus something squared is just because of, that's the height. That's the y value. 5 minus 2 squared. And so we're going to do 5 times 4. When I do this, I get, ooh. I don't know how I got this. This should have just been 8.25. So my bad about that. Then minus 4. There, I get 6.25. For the midpoint one, we're going to do 0.5, and instead of, we're not going to use 0 or 0.5, we're going to do the average of these two. So it's going to be 5 minus 0.25 squared. 5 minus 0.75 squared. 5 minus 1.25 squared, and then 0.5 times 1 minus 1.75 squared. Okay? So we're going to do 5 times 4. This one I'm going to get 7.375. Okay, and then let's finally do the trapezoid rule. Trapezoid rule is I'm going to do 1/2 the height times the sum of the two bases. So that's going to be 5 minus 0 squared plus 5 minus 0.5 squared plus 1/2 times 0.5, 5 minus 0.5 squared minus 5 minus 1 squared plus 1/2 0.5 5 minus 1 squared plus 5 minus 1.5 squared plus 1/2 times 0.5 times 5. Oh, I shouldn't be squaring in these parentheses right there. I think I kind of messed that up. Yeah, this square should have been inside. Okay, 5 minus 1.5 squared plus 5 minus 2 squared. 1, 2, 3, 4. So those are my 4 rectangles, four trapezoids. Okay, so as you can see, they get a little bit tedious to do eventually. So you're going to do 5 plus 5 minus 0.5 squared. Okay. And I get 7.25 when I use my calculator. So the area is somewhere in that range, in those ranges, right? Okay, so let's let me actually move a few of these down a little bit, make a little bit more space. Yeah. Okay. So we're going to do the same thing for this one here. And hopefully it makes sense now what we're doing. In this case, the whole width of the interval is going to be 2. Okay, and then the number of rectangles, so the width is 2. So that means each rectangle has a width of 0.4. Okay. And then if I were going to do the leftmost points, I'm going to use the x values. You could think of it as x value tables. I'm going to do 0, 0.4, 0.8, 1.2, 1.6, 1, 2, 3, 4, 5. So this is kind of another way you can kind of you can make this table. Maybe this would be an easier way of doing it, to do all of these at least, to just demonstrate how you would come up with them. So if I'm going to have a table of x and my f of x, which is equal to x plus 3x cubed. Okay, so say I'm going to make this table here. So my x values are going to go 0, 0.4, 0.8, 1.2, 1.6, and 2.0. So that's the whole interval. And you see that the spacings indicate each of a width of 0.4, and there's 1, 2, 3, 4, 5 spacings. So there's going to be 5 rectangles. It's just for each rule I use a different one, either the left or right hand rule. So f of x is 0 here. So here's going to be 0.4 plus 3 times 0.4 cubed, which is 0.592. Here I'm going to do 0.8 plus 3 times 0.8 cubed. It's 2.336. Here is going to be 1.2 plus 3 times 1.2 cubed. 6.384. Going to do the same thing with 1.6. 13.888, and then 2 plus 3 times 2 cubed is 26. Okay. Now, when I do the right-hand sum, what I'm going to use, so my right-hand sum is going to be, so for A, Sorry, left-hand sum. Left-hand sum is first. I'm going to use these 4 points as the heights. These 4 heights right here, or these 5 heights right here as my rectangle. So my rectangle is 0.4 times this height, 0.592, plus 0.4 times 2.336, plus 0.4 times 6.384, plus 0.4 times 13.888. And that is my 1, 2, 3, 4. What did I do? Oh, and I forgot the 0 times 0. 1, 2, 3, 4, 5 rectangles, right? So doing this is 0.4. Really, a shorthand that some people do is take out the 0.4 and just add these heights together. So, because I can factor out the 4. And that's equal to 9.28. When I do the right-hand sum, we do the exact same sum, except I use these values for the height instead. Okay. So this will give me 19.68. When I use the midpoint, actually I have to use different values. I'm going to use 0.4, but then I got to plug it in for point. So for midpoint is a tricky one because I don't use any of these values. I do 0.2, 0.6, 1.0, 1.4, and 1.8. And I plug it into these heights. I get these heights. So I need to plug in this case, f of 0.2 plus f of 0.6 plus f of 1.0 plus f of 1.4 plus f of 1.8. And again, these are still 1, 2, 3, 4, 5 rectangles. So give me a moment while I do that one. So it's going to be u plus 0.6 plus 0.6 cubed plus 1 and then 1.4 and then 1.8. I get 13.76. So you see the midpoints between these two. And then finally trapezoid, I average each of these two and then multiply by, so I'm going to 0.4, but then I'm averaging each of these. Okay, so I average this value, multiply by 0.4. I average this value, multiply by 0.4. I average the two y values. Those are the two bases, right, for the trapezoid. Okay, so I'm going to do 0.4 times the average of those two. And I get 14.48. That's what I got. Okay. Same thing here. We're going to set up our table. Now the interval is 2 and its n is 4, so that means it's going to be 0. That means each rectangle is going to have a width of 0.5. So 4 to the 0 is 1. 4 to the 5th is the square root of 4, which is 2. 4 to the 1 is 4. 4 to the 1.5 would be 8. And then 4 squared is 16. Okay? And so for the right-hand sum, I'm going to use these 4 as my heights of the rectangles. So it's going to be 0.5 times 1 plus 0.5 times 2 plus 0.5 times 4 plus 0.5 times 8. They're the left-hand sums because the x's are all the smaller ones. And so that sum is going to be 15 over 2, 7.5. And for b, for the right-hand sum, we're going to use these instead. So it's going to be 0.5 times 2 plus 0.5 times 4 plus 0.5 times 8 plus 0.5 times 16. And so that would be 10 plus 20, 30 divided by 2, it's 15. Midpoint, I could do 0.5 times 4 to the 0.25 plus 0.5 times 4 to the See, I have to use the midpoints, what's in between each of these, which is 0.75. 4 to the 1.25, and then plus 0.5, 4 to the 1.75. I have to use my calculator for that. I get 10.6. And then the trapezoid rule is I average each of these. So it's going to be 0.5 times 1/2 of the sum of the two bases, 1 plus 2, times the average of the bases, 2 plus 4, average of the two bases, 4 plus 8, 8 plus 16. Get 11.25. Okay. Same thing here. We're going to make a table. X, f of x. Now this is interval 3. The width is 1. So we're going to go 1, 1 and 1/3, which is 4/3, 5/3, and then 6/3, which is 2. Right? And each spacings is the width of a rectangle. So I have 1 spacing, 2 spacings, 3 spacings, 3 rectangles. And so this is going to be ln of 1 is 0, ln of 4/3, ln of 5/3, and ln of 2. Those are the heights. And so when we do A, the left-hand sum, I'm going to use these three. So I'm going to say 1/3 times 0 plus 1/3 of ln of 4/3 plus 1/3 ln of 5/3. And so that's, I don't know, you could just 1/3, when I sum logs, so I can factor out the 1/3, and when I sum logs I can multiply. It's ln of 20 over 9, right? Because ln of 4/3 plus ln of 5/3, I just multiply the insides. So that would be that one. And for the right-hand sum, I'm going to do these three instead, right? Third ln of 2. So that's going to be 1/3 ln of, and that's what I'm going to multiply all these. So 2 times 20, it's 40 over 3. Okay. For the midpoint, I'm going to do the halfway between 1 and 4/3, and that would be 7/6. And then halfway between these two be 9/6 or 3/2. No. 9 over, sorry, sum them up divided by 2 would be 9 over 3 divided by 2, 9 3/4. Wait, is that right? This shouldn't be 5/3. 1/3. Oh yeah, it should be 5. Oh yeah, it should be, yeah, it should be 3 halfway. It's 9, sorry, 9 over 3 divided by 2. This should be 3/2. Thinking, I'm not sure what I'm thinking. And then 1/3 times ln of halfway between 5/3 and 2 is 11/6. So that would be 1/3 ln of, I would just multiply, sorry, this is 3/2. Multiply all these out. 21 over 72, something like that. I could technically take out a 3, but that's fine. Trapezoid rule, I'm going to do the height times average of the base. So 0 plus ln of 4/3 plus 1/3, 1/2, 0 plus ln of 4/3 plus ln of 5/3. And then last one is 1/3 times 1/2 ln of 5/3 plus ln of 2. So I can factor out a 1/6, and it's going to be ln of 4/3 plus 2 ln of 4/3 plus another ln of 4/3. So that's 2 ln of 4/3 that 0 doesn't count. And I have an ln of 5/3 here and an ln of 5/3, 2 ln of 5/3, and then plus an ln of 2. And then I could square and multiply. This would be 1/6 ln of 16 times 25 is 400. 400 times 800 divided by 9. 9 times 9 is 81. Like that. Okay. Kind of tedious to do all the summations, but hopefully it makes sense, like why I use the left and the right most points. A lot of times you're going to be given tables of datas, and you need to just sum up the estimated area. That's the most common way that that problem manifests. So let's look at some examples where it's not so uniform. Like it's like I have like a table of values, and this is very common on the AP exam. You get kind of like these table values instead, where you're having to and it's not interval width. So you're still going to do the left and the right hand sums. It's just it's not a predefined integral. You're just giving a function, and they would like you to find various areas by doing left hand sum, right hand sum. So here, I want to do the area of f of x between 2 and 8. Now, the way you start is I look at the x values here, and I look at the interval widths. The interval widths is 2, 3, and 1. So those are like the interval widths there. Like that's the width of the rectangles. And then the height of the rectangle is actually kind of easier. When you're doing the left-hand sum, okay, you just take the left value. So you would say 3 is the height of the rectangle, and the interval width is 2. So that's the width of the rectangle. And then this one, the left point, is -1, and the interval width is 3. And then here, you take the left point, f of x, which is 2 times 1. And so this would be 6 minus 3. That's 3. 3 plus 2 is 5. And then when you do the right-hand sum, you do almost the same thing. You're going to take, except you're going to use the right endpoint. Between 2 and 4, you're going to pick the right value. So it's -1 times 2. And on this interval width from 4 to 7, interval width of 3, you're going to pick 2 as the height because that's the right-hand sum. And then here, the right value, 9 times the 1 there. So you get -2 plus 6 is 4. 4 plus 9 is 13. And then trapezoid rule, what you're going to do is you're going to average the 2. So on the interval width of 2, you're going to average the 3 and the -1. And then similar thing here, I'm going to average the -1 and the 2 times the interval width, right? Still rectangles, it's just sort of like the height of the rectangles, like the average of the 2, right? And the interval width from 7 to 8, you're going to do average of 2 and 9, right? And what's it? This is 1. Sorry, this is 2 because this is 1 here. This is 1/2. This is 3 halves. This is 11 halves, right? So 14, that's 9, I think. Okay. How about we do the same thing for g of x, all right? So left-hand sum. Okay, interval widths are kind of the same, but now I do the g. And again, for the interval from 2 to 4, the height is 0. So you can do 0. You're going to use the left point, 0 times 2. Then here from 4 to 7, the left point is 3. So then 3 times 3. And the interval width from 7 to 8, the left point is -5. -5 times 1. And that's going to be 4. And then the right-hand sum, on the interval width, you always pick the right value. So it's going to be 3 times 2. And I'm using g of x here. And then I'm going to do -5 times 3. And then I'm going to do the right-hand point of this interval, -2 times 1. And I'm going to get 6 minus 15 minus 9 minus 11, I guess. And then trapezoid rule, you just average the 2. So I'm going to do 0 plus 3 over 2 times 2. Then 3 and -5 I average times the width of 3. And then average these 2 times the 1. So hopefully it's making sense, right? You're just simply looking at the table. You're either looking at the left or the right or the average. If you're doing midpoint, then you have to grab the point in the middle, but that's less common. So this is 3. This is -3, and then this is -7 halves. That's -7 halves here, okay? Kind of wildly different values, but that's okay. There's a close approximation. What if you do like something that's different, f of x times g of x? I want the area from 2 to 8x, g of x. Well, I would just need to make an entry in my table here that multiplies these two. Like this would be 0, -1 times 3 is that a 0.3? Oh, I'm just going to assume it's a 3. I think it's a little blip. I was assuming it was 3. Negative 1 times 3 is negative 3. 2 times negative 5 is negative 10, and then negative 18. So we're still going to do the same thing. It's just now your interval width's like this, but you just pick the... Oh, sorry, let's do left-hand sum first. Left-hand sum, we're going to pick the left point, which is 0. Then the 3 times the 3. Then the negative 5 times the 1. Or, sorry, negative 10 here. So, oh, this is minus 3. Sorry, I could have messed up. Negative 3 times 3, yeah. And then negative 10 times 1. So this would be minus 19. And then when you do the right-hand sum, you would pick the right value instead, right? So it would be negative 3 times 2, and then negative 10 times 3, and then negative 18 times 1. And then you would get negative 6 minus 36 minus 54, I guess. Yeah. Just some of the arithmetic there. And then trapezoid rule, you're just going to average the two. 0 plus negative 3 over 2 times 2 plus the negative 3 and the negative 10 over 2 times 3. And then negative 10 plus negative 18 over 2 times 1. Okay, and I don't know, this is negative 3 minus 39 over 2 minus, what's that, 30, so 28 over 2 minus 28 over 2 is minus 14. Right, so it's, I don't know, I'm just going to use a calculator for this. The numbers just didn't come out too great. It's not really that important. Minus 73 over 2. Okay. And then, you know, it's kind of always the same thing, right? With the x squared f of x, like number 9. Again, from the table, I can construct what x squared times f of x is, right? You just say, well, 2 squared times 3. 4 times 3 is 12. 16 times negative 1. Negative 16. 49 times 2, 98, right? And then 64 times 9. Ooh, these are ugly numbers. 576. Usually on the AP exam. You know, on the AP exam, it's actually okay to just write out the sum and not actually compute the numbers. Left-hand sum, we're taking the left point, which is 12 in this case, times the interval. And then the second interval from 4 to 7, the left point is negative 16. And then here, the left endpoint is 98 times 1. Again, not important, super important to actually do the computation on the free response section. It's okay to just sort of put the expressions, and you can use a calculator for that. It's not a big deal. I'm going to skip the calculation. So on this interval now, when I'm doing the right-hand sum, I pick the right point. And then I'm going to pick the right point on this interval. The right point would be the 98. Oops, times 3. And then the right endpoint here is going to be 576 times 1. And then when you do trapezoid rule, you're just going to average the left and the right interval times the interval width. And then again, average for this interval, you're going to average these two values here. And then for the last interval width, you're going to average the 98 plus the 576 times 1. Again, you can use a calculator, get the numbers. It's not a huge deal. But that's how you handle it for a table.